Hi there. In this final video in the series, we're going to go through a 5D by meshes toolpath operation, which is a full 5-axis interpolated operation using the turntable not as an indexing tool at this point, but as a fully live tool. So to do so, we're going to return to the machining tab. We're going to click on Add Operation, go to 3D 5D Advanced, and we click on 5D by meshes. Now we can see that we've already got a different tool defined in there, a 30mm spherical mill, a ball nose if you will. This is perfectly okay for what we need. So the first thing that we're going to do is we are going to change the tool orientation because we don't want it to come from the right like this. We prefer it to come from the top for this. So to do so, we go back to tool orientation, click to pick, and we are going to set X to 0 and Z to 1, and then click on OK. The next thing that we're going to do, because we're going to be using the turntable as a live axis in this instead of as an indexing axis, I'm going to enable rotate E2. So this will allow, during the course of the toolpath, the turntable to rotate freely according to what's required. However, in doing so, we do need to define the rotary table vector as well. It will automatically do the best that it can. However, what we're aiming for really is positive X. So it still comes in from the same approach angle that it did previously, although now we've defined it according to the turntable's frame of reference as well as the robot's frame of reference. So I'm going to go to strategy now, and for the sake of making this toolpath nice, I'm going to set spiral machining, and also for the sake of being able to calculate this a bit more quickly than doing a full calculation, I am going to set the bottom level to be higher than it currently is, maybe only going halfway down its face, just so we've got a nice sanity check without having to invest all of the time in generating and calculating the toolpath. So I'm going to take a quick look through the other settings. We've got avoid collisions and side tilting turned on. This is good. However, we need to check that check spindle is turned on as well, because otherwise we won't have that exclusion zone set around the spindle. So we click on check spindle again, and I am going to have a look at these settings, and they all look good so far. So the next thing that we're going to go for is we are going to click on generate toolpath, and once that's generated, we're going to run the first simulation. Now already we have an issue, and the issue is in the wrist axis of the robot here. It's not happy with its current position. That's fine, we have an easy fix for that because this is a relatively common issue. We can click on flip wrist joint 5 and then regenerate the toolpath, and already you can see you've got a nice clean toolpath here. There's no problems with the axial definition of the wrist at the moment. It's not highlighted in red, so everything's happy. Sometimes you will find that you will get axes coming up in red here. That's not a massive issue. If it bothers you, you can change the current position of it slightly, because obviously robots are defined to go to plus or minus 179 degrees instead of 180. So we set that to 170, not a problem. Click on generate again, and that red error should clear. There we go. So we now go to the simulation. Since we've already got this run up to the end of the roughing waterline for now, we don't need to reset anything. I am, however, going to slow things down just to make sure that everything's good on the approach, and then I'm going to click run. Possibly not slow it down that much. And so the robot approaches the top of the workpiece, and we should start to see the effect of the side tilting fairly soon. There we go. So as the robot is working around the more complicated angles of the 5D toolpath for the surface, it will tilt the head out of the way of the actual workpiece progressively, which is a much, much safer way of working than just letting your best guess it, which is why we always make sure the side tilting and the check spindle settings are turned on, so it checks for all of those interactions for us. So this appears to be good so far, so I'm going to increase the movement speed now and let it work all the way down, keeping an eye out for any errors that happen. And so far we've had none, so this is looking pretty good. Excellent. So we now have our Batman bust finished all the way down to the jawline. So what we can do now is we can go back to strategy, and I've already seen a problem here. We have not set the rotary axis to be in line perpendicular to the tool table. It's currently in line with the tool axis, which is what gave us that slant there. So I'm going to set this rotary axis to use the world coordinate system defined as Z, which means we've now got a perfectly vertical toolpath. It will change the approaches that we had slightly there, so we need to check and resimulate it. So we'll do that now. Pause the recording there just to save you the time. So we now go back to simulation, reset, and then simulate up to current operation. Slow it down a little bit, press run, and you can see we've still got a nice clean toolpath so far. Speed this up to make sure that everything's still happy. Perfect. Notice how we've now got a straight line across here instead of the slanted angle that we had before, because we've defined Z as the direction around which the rotational axis of the robot head should be operating. I'm going to go back to the machining tab now, and I'm going to lower the bottom level all the way down to where it was previously. So an easy way to do this, instead of defining an arbitrary value, is just to click on auto, and it will go down to the bottom of the actual workpiece by default. So we're now going to regenerate this toolpath. I'll pause the video at this point to save you the time. Okay, that toolpath is now happily defined. So the next thing that we're going to do is we're going to simulate it and see how it's looking. So again, reset, up to current operation. And we'll leave it running at this speed for now, since we know that the approach is good. Let's click on run. And slow it down a little bit at this stage, just so we're 100% able to see everything that's going on, because obviously the angles and the contours are a bit more complicated now that we're down around the shoulders. Okay, all appears to be good with this so far, so I'm going to speed it back up, and we should be able to catch any errors as they happen still. And we have a perfectly happy toolpath at the end of that, which is marvellous news as far as I'm concerned. So what we do now that we've got the toolpath that we're happy with and the end result that we're expecting, go back to the machining tab, and I would like to generate the code to be able to run this on a robot. So we're going to click on post processor now, and we are going to choose the appropriate post processor, although it's already done for us here. So we have got the KUKA robot post processor, and it saves it in a pretty standard looking folder there. I'm going to click on run for it to generate, and it tells us that the ENCY output folder does not exist yet, That's fine. We're going to click yes, because it will generate a new folder for each project as we go through it. Oh, no, it doesn't like the definition of the placement for it. So instead of it being in D here, we're going to click on the down arrow and we're going to click on Open Dialog, which allows us to select where we want to put this. So I'm going to put this on the desktop for now, because it means that we now have a nice and easy way of finding the file. So I'm going to click on Open and then Run. And once the scroll bar is completed, we now have the full file that the robot is going to be using to carve this for us. So I'm quite happy with how that is now. We're going to click on Show in Folder. So we can see now that on my desktop folder, we've got the Batman ENCY SRC file, which our KUKA robot will fully understand. So that's taken us from a complete start to a complete finish on the Batman ENCY bust project. I will catch up with you guys on the next one. Thank you for your time.